Welcome friends. So, as we are discussing that there are multiple scenarios for handling the inventory related issues in our operation management case, and we see that lot of analytics can be used in understanding that how things are there in the past, because whatever uncertainties are there, these uncertainties are coming because of our historical data. We understand that how things have happened in the past, and using those historical information, we try to take good decisions, and all those good decisions using different kind of algorithms are part of predictive analytics. And in our previous sessions, we have discussed that you have uncertainties in the demand, you have uncertainty in the supply, you have uncertainty in terms of lead time also. Then there are possibilities of quantity discounts. There are issues where suppliers are not ready to give you instant supplies. These supplies are happening at a particular rate at which you are getting the replenishment. All these are the different type of situations we have discussed in case of inventory related decisions. Now, moving further, we also can see that inventory decisions can be broadly classified into two categories, and these two categories are deterministic and stochastic. Wherever you have definitive ideas, these are the deterministic situations. But when you do not have complete information, whenever the information is in a possible mode, these all are the stochastic situations. Now, in the stochastic situations, you have different possibilities, that okay, possibility 1, possibility 2, possibility 3, possibility 4, multiple possibilities are possible, and each possibility may have its own weight also. So, how these uncertainty or the stochastic nature is to be handled, that is what we are going to discuss with the help of another very common tool, that is decision tree approach, and we will have some kind of illustrations also in this particular session explaining the use of decision tree in our decision making activities. We all know that there are so many different types of decisions we take in operations management. Right now we are talking in the context of inventory. If you stock one additional unit, for example, whenever we are talking about inventory and revenue optimization, we will see that should we stock one more unit, whether by stocking one more unit our expected profit is going to increase or decrease. These kind of decisions are very common, and with the help of this particular tool which we are going to discuss in this class, decision tree, you can very conveniently make such kind of decisions, like investment related decisions in plant size. What should be the capacity of your plant, whether you should have a plant of 10,000 units or 20,000 units. Depending upon what should be the possible demand, and then there are different possibilities of demand level, whether you are going to use the capacity of this plant in a better way or this plant in a better way. You have answers available to you, and generally now we have two types of uncertainties. The uncertainties which are for really for very short term periods, and uncertainties which are going to have long term impact also. For example, the size of the plant, location of the warehouse, the size of the warehouse, these are the decisions. If you take any kind of wrong decision in these, the impact can be long lasting. If you do not stock enough number of items in a order cycle, the impact is very small. Only the particular order cycle is getting affected because of the wrong inventory decisions. But because of the wrong decisions of the size, wrong decision of the location, the impact is much more long lasting, and therefore, we need to be more careful when we are taking decisions in the long term terms, and uncertainties are there in those long term issues also. Where, for example, if I take in case of India, should I make a plant in Mumbai or should I make a plant in Delhi? Now, you are not going to make plant on a daily basis. So, if you take a wrong decision, Mumbai versus Delhi, this is going to be having a permanent impact on your business. So, you need to see that uncertainty is there. Neither you are clear about Mumbai situation, that how business environment in Mumbai going to unfurl, and how the business environment in Delhi will be there in future. But based on some kind of estimates, you will see that what is the expected payoff. If I take a decision in Mumbai or if I take a decision in Delhi's favor, what will be my expected payoff, and we always want to maximize our expected payoff, and for that purpose we will see the application of our decision tree. So, decision tree is a very simple, you can say, pictorial representation of all the possibilities which may happen in future. So, it is beginning with the initial decision and ending with all possible outcomes and their respective payoffs. We are using two types of symbols in the decision tree as we are progressing. Whenever a square is it is to denote a decision nodes and a circle to denote the uncertain events. Like this. So, this type of tree and its branches will keep developing after every decision node and every uncertain events. Here you see a sample decision tree diagram, and where all the important terminologies related to decision tree are mentioned. As I already mentioned, a square symbol is representing the decision node. So, I take a particular decision. Decision can be either I can open a large factory or medium factory or a small factory. I can take three decisions: opening a large factory, medium factory or a small factory. Whether I open large factory or medium factory or a small factory, there are three possibilities, that is uncertainties. Economy may be very strong, economy may be moderate, and economy may be weaken also. You can say optimistic, pessimistic and BAU. Stable economy are represented as BAU. BAU means business as usual. So, these are the three scenarios which are possible. I do not know which scenario will be there. Based on various estimates, I have the probability that chances of strong economies are 30%, stable economy business as usual 50% and weak economy 20%. And on the basis of that, you have, if there is a large factory, if I am opening, these are the different kind of scenarios. In the bracket, in the blue color, these numbers are basically probabilities. You please note down that these probabilities are sum equal to 1. For every decision, whatever all possible situations are coming, uncertainties are happening, the sum total of their probabilities are 1. Now, if I am opening a large factory and economy remains strong, I may gain a profit of 200 rupees. If stable economy is there, I will gain a profit of 50 rupees. But if I open a large factory, but economy is declining, I may get a loss of 120 rupees. And so on. I have mentioned for other scenarios also with respect to my decisions of opening a average factory, moderate factory or a small factory. So, here these are the payoff. So, you have understood decision node, these are the alternative decisions and these are the alternative situations, scenarios, and these are in the bracket their probabilities, associated probabilities, and then these are the possible payoff for all these decisions in a particular scenario. Now, my objective is here to maximize the payoff. This is what I want, and for that purpose, if you see simply, I will like to open a large factory, because if economy is going to be strong, I will get a highest payoff of 200 rupees. But what if economy is weakened, then probably I will take a loss of 120 rupees also. So, you can say that I am not sure whether economy will be strong or economy will be weak, but on one side I may gain up to 200 rupees and on the other side I may have a loss of 120 rupees. On the other side, if I open a small factory, whether economy is strong, stable or weak, I will always have a positive payoff, though this positive payoff is very small, 40, 30, 20, but still I will be never in loss. So, if I am a risk aversion person, I will not like to take risk, I will not like to go for losses, I may go for these kind of scenarios. But on the other side, I am ready to take risk also. So, if I want to take risk, I will go for large factory. But how to take more rational decisions in such scenarios, that is what we are going to discuss. So, here we can see that the payoff of opening a large factory, that is calculated with the help of this term which is known as EMV. EMV is mentioned in the bottom of the slide, that is expected monetary value. So, I am going to take three decisions, either I am going to open a large factory, medium factory or a small factory. I have to calculate expected monetary value of my these decisions. Expected monetary value of opening a large factory, EMV large, will be payoff multiplied by associated probability. So, in the Excel we can use sum product. I will recommend to use Excel sum product of payoff and associated probabilities, and this function will look like this way, and then you will calculate the associated EMVL as 61 rupees. Associated expected monetary value of medium size factory is calculated by multiplying respective probabilities and their payoffs, it will come to be 81, and expected monetary value of a small factory will come out to be 31. Now, out of these three expected monetary values, it is now very easy for you to make a decision that since expected monetary value is highest for medium size factory, we have written it as average factory, you will always take a decision for this particular case. You have maximized your expected monetary value by opening the medium size factory, and this is how you can take the decisions without much difficulty. In this case, the challenge is how are we determining the values of these probabilities. So, lot of you can say efforts are there that we should be able to predict these probabilities using our historical data, that we can take the data of last 10 years, 15 years, that how economy is going to be there in the future, and on the basis of that these probabilities are assigned. Now, we can take a different case. This is how we understood the use of decision tree in our decision making. Now, we are taking a case where we are having some historical data, and that historical data is with respect to two important factors, that I have to see how demand is going to increase from period to period, and on the basis of that I have to make some important decisions, maybe decision related to capacity, decision related to my facility location, etc. So, here I am going to tell you that how decision trees will be developed. Now, I am considering two variables. In this example, we considered only one single variable, that is what is the total payoff. Now, here I am considering two things, one is price and another is demand. Now, as we are going from one period to another period, that factor is either increasing or decreasing with a particular probability, and this is represented in this particular case using a particular probability distribution, which is known as binomial probability distribution. So, for example, if I say only one particular factor p, so price in the factor period 1 is p, in the beginning of period is p. Now, price can increase and price can decrease also. If it is increasing, it is up, I am saying it will increase by a factor of u, it is decreasing by a factor of d, and then in this next period it is again possible to increase or decrease, it is also possible to increase or decrease, and so on from period to period this kind of changes are happening, and this is what we have represented in this lower part of the slide also. Here you can see with the help of a decision tree also in a graphical manner that how these probabilities are explained in a sequential manner. So, let me use some space for that purpose. If in the beginning the price is p and then it is increasing and decreasing with a particular probability, so after period 1 this has become pu or pd. For our purpose, I am associating equal probabilities for both these branches, that in period 1 there are 50% chances the price will up by a factor of 10% and price may decrease also by a factor of 10%. U and D are plus minus 10%. Prices are increasing, decreasing by 10% and the probability are 50% each. After period 1, again in the second period the price may again increase with a probability of, so this will become pu square, 10% further increase in the price, 50% possibility is price may decrease. So, price is decreased by again d percentage. So, pu into d. Here also it is possible that price may increase. So, pd into u it becomes pud and price may also decrease. So, in that case it becomes pd square. This is what we had in the period 1 pu pd, in the second period pu square, pud and pd square, and then in the third and fourth period you can create similar table to extend. everywhere, but it is very interesting and maybe one of the questions also in our weekly quizzes, that out of all these different branches, there may be some branches which are common. So, you will actually here, just by the diagram, it appears that there will be 6 different prices, but as we saw in the second period, though there may be 4 different prices, but practically when we saw, these are only 3 different prices. So, similarly in the third period, theoretically it appears that there will be 6 different prices, but actually these are not 6 different prices, it will be 4 different unique prices, and so on. As we have more number of periods, your tree will be bigger and bigger, and in this way we can always create a more generalized way of writing this particular thing, that the type of u and d which we are discussing, these are multiplicative. Multiplicative means a price with me in period 0, initial price P naught is, let us say, 100 rupees, and u and d are 10%. So, in period 1, when I am saying it is Pu, that prices have increased by 10%, that is 110. Prices have decreased by 10%, it is 90%, 90 rupees. When I say in the second period, prices are further increasing by 10%, so Pu will become 121. Prices have reduced by 10%, so 110 minus 11, that is 99 PUD. Prices have increased by 10% for PD, 90 plus 9, and prices have reduced by 10% PD square, 90 minus 9, that is 81. So, that is the meaning of multiplicative distribution, and in this case all possible outcomes can be determined for a particular period using this particular simple generic you can say formula. Now, there can be additive situations also. In additive situations, if initial price is 100 rupees, I will say that price will increase or decrease by 10 rupees. So, in period 1, price will become 110 or 90. Period 2, 110 plus 10, 120, 110 minus 10, 100, 90 plus 10, 100, and 90 minus 10, 80, 120 plus 10, 130, 120 minus 10, 110, 100 plus 10, 110, 100 minus 10, 90, 80 plus 10, 90, and 80 minus 10, 70. So, these are the cases of additive binomial distributions. So, in this way we are able to create our let us say decision tree, and in this decision tree you also need to assign the probability. And these all are basically part of this particular part of our discussion, that how over a period of time, if you are opening a large factory, average factory, small factory, and based on these particular scenario, if you have this much of price and these kind of situations will happen, you will earn a particular expected profit, expected monetary value, and accordingly you may take a decision whether you should go for this kind of decision or not. So, how you are going to represent your different kind of additive or multiplicative possibilities on the decision tree, that we have discussed. Now, based on this, managers can make a very good choice between their long term options, short term options, and on the basis of these things we will see in our next session that we are able to make very interesting and very accurate decisions that whether option A is better or option B is better. We will see with the help of a facility location problem that there are multiple type of options and how using the decision tree we are able to decide that which option is better. So, with this we come to end of this particular session where we understood how are we going to construct the decision tree, and these decision trees are going to help us in making a decision which are very simple to analyze because everything is graphically available in front of our eyes. Thank you very much.